Hi everyone, I'm Shubham and Shiva.
Okay, I'm Shivam.
And both of us work in ShareChat. We used to work in platform team earlier where we did a lot of this work on Benthos, which is now called Red Panda Connect, was the acquisition. And then we currently work in the live team where we are continuing this legacy of using Benthos everywhere in ShareChat. And we are giving our talk on the same. So first thing, like how many people have heard of Benthos here or Red Panda Connect? One, two, three. Okay. So Benthos is a very interesting, I would say, stream processing system. So it's like a declarative system where you define things in YAML. And the most important thing to note here is like it's stateless, unlike a lot of other things. But the best thing about it is very simple. So for example, like usually you have a lot of very simple tasks like transformations or conversion from one format to another format, which are like the bread and butter of streaming. And we often write like a lot of jobs for the same, like in jobs in Java, Golang, Node.js, or whatever language you are comfortable in. And it is often overkill, where when you can just write a simple YAML and be done with it. And the thing is, it provides a lot of sources and syncs. Like if you go to the official website, you'll be surprised like the amount of sources and things we have. It can connect to literally every, I would say, queuing system, database, etc. Or and it has a source of sync for that, and it works amazingly well. Like I have seen Benthos, which is not tuned, working better than like tuned jobs in production. And the best thing about it is like since it's a like full stream processing system, it provides a transactional model and it has at least once delivery guarantees for sources and things that have the delivery guarantees. And it is completely stateless and it has no things such as disk persistence. So you can auto scale it as you want and it is very simple to operate. There's no cluster, etc. All those things. And it is written in Golang, by the way, and a single binary. It's a single binary that you can deploy in production. So you can easily extend it with writing your own functions in Golang and add it to Benthos. Uh, and the most important thing, like it provides a lot of support for, I would say, like tracing, logging, and observability, which is the trifecta of, I would say, what you need to see if system is working in production or not. So that is on Benthos. This was the probably the slide which has the largest amount of text. You'll probably not see so much text for a long while now. So I would say like why Benthos? So why Benthos? So I would say like a use case why we started. So we had a Java job which did some ad hoc transformations, and we had like a lot of similar things where you read from a queue, do some enrichments, and write to another queue. And we realize it's not the best use of developer time or bandwidth to spend any energy on these jobs if you can like get a system to do it for you. We had like data flow, we had Flink, we had Kafka streams, and also we recently also have Spark streaming, which are all very good systems. But then the thing is, setting up such a system is a hassle. Like I would say, like Spark, you need a cluster, Flink, you need a cluster. Kafka streams has its own set of like limitations. The thing about Benthos is just work. And honestly, like some people might say, like, why not just write a job in a language? And I would say that interactions with queues are actually not that simple. We have seen it like people doing the same mistakes time and again. Where, for example, people are not following the best practices. For example, like Google PubSub recommends you to use streaming pull. Now, if you're doing streaming pull in like I would say Node.js, it's a difficult like concept to get around, like how you use streaming pull. Benthos uses streaming pool by default. You just write the PubSub subscription name and it works. So, and to cement this further, I would say like this is like how you would deploy Flink on Kubernetes. Like this is actual production deployment of Flink. And we actually use it because we have a Kubernetes operator for Flink that we use in production. And there are a lot of components. There's a job manager, task manager, and all of these like Kubernetes API server, etc., etc. So it's complex. And then I have deployed it in production, and I know the amount of effort required and the amount of tickets that need to be raised to DevOps to get this through. And then this is Ventos. Like it's a simple YAML and it just works. Like that's it, I would say. Because you can just have a simple deployment, just like you have for any service or any job. You don't need any cluster, etc., and it will work. Like it's as simple as deploying any other service. Like there's no specific cluster that you need for it. And I would say then again, like why? some more reasoning like why Benthos and then why we got to it. Like, so this is like a very good diagram that I copied shamelessly from one of Netflix articles where they were talking about like what is like a stream processing system and what are the different categories they fall into. So they had something called Mantis in internally in Netflix, which is like a low latency and a low cost system, which is used for operational workloads or where you don't require state. So I think Benthos fits pretty in that same space where it is very cheap and it is very fast. And then you get both of those. You don't get a state like that you get in Flink. So you can go for Flink or like Spark streaming for those use cases, but it works for those simple ones. So I think with this, I'll give the microphone to Shivam to discuss on how we started at Benthos.
Yeah. Hey guys. So I'll talk about how we introduced Benthos in ShareChat. The first POC we did. So I was on the internet at that time and like Shubham was my buddy. Right? So I'll just talk about the first problem statement. So we had a Java job, as Shubham said, and we wanted to kind of like provide use cases where people want to just simple to ETLs, say simple transformations. But here the input was same, but the output can be different. It could be a Kafka topic, a PubSub topic, a API call, or maybe a cache. Now writing it in Java, it was basically it was a hassle. And then the challenges were basically, again, as I said, output can be varied and a lot of boilerplate code, right? For every different output and input, I had to write a separate class in Java. Then again, I'll have to couple them basically integrations and same delivery guarantees. I cannot provide delivery guarantees for every, I would say, output, right? By default, I will have to basically write separate logic for each of them. Then again, Java jobs are resource heavy. They are costly as compared to normal, I would say, Golang job, right? So again, I'm showing you this is simply a single consumer which consumes from Kafka, decodes the message from protobuf, right? Transforms it, again encodes it to protobuf, and then sends it to a PubSub top. Single function. Again, this is not a single use case. Again, like this, I'll need multiple functions, multiple use cases, multiple classes. This is a single Benthos job, complete job. This is consuming from Kafka, converting JSON to protobuf to JSON, sorry, transforming it, and then sending it to PubSub. This whole config is just a single file that can be deployed as a separate job. You don't need to write any other logic. You get all the delivery guarantees. You can control threads and all that, right? Okay, so basically, right, technically they are same, right? Single job that consumes from PubSub writes to Kafka with transformations. The same thing here. It seems like they are the same picture, right? But are they, right? So with the Java, as you keep on writing, as I said, right, you keep on writing, it balloons up. You have multiple classes, multiple functions, DAOs, and then integrations and so on, right? Again, for Proto, then resources for staging, production. And then in ShareChat, we have multiple organizations, ShareChat and Moj. So for them, we have different properties now. This is the starting job. Then we realized we could not maintain it for the long term. Again, we had to find something that we can manage, that we can scale without worrying about ballooning code. So this is Benthos. What you see is what you get. Now, this is the Benthos input. I'm saying consume from Kafka. These are the topics. This is the consumer group and start from OLS. That's it. Nothing else. It will maintain everything for you. It will provide delivery guarantees, commits, and so on. This is the pipeline. Now I have said, okay, this is the input. Now, how do I process the messages, right? So this is a single pipeline. I'm saying, okay, in a pipeline, use as many threads as there are codes on the machine. Protobuf, convert to JSON. Whatever message you are getting from Kafka, convert it to JSON, enrich it. We are doing some transformations. And now output, like again, our message is ready to be sent to PubSub. I'm saying, okay, this is the PubSub, this is the topic, send it. Nothing else. Now, everything else, every delivery guarantee, as I said multiple times, is being taken care by Benthos. Again, now we need logging and metrics, right? I don't want this to be a black box. It is provided inbuilt by Benthos. You just say, okay, I want log levels, I want info logs, again, time spent, and any custom field you want. And then I want Prometheus metrics. That's it. You'll get the metrics. I'll show you the dashboard at the end, how these metrics are again provided. Now, this is the first message we sent when we were doing the POC for Benthos, right? We are realizing that the Java job that we have written was not scalable without, again, multiple like developers working on that. With Benthos, we realized, oh, it can process 1,000 messages per second with a single pod, 200 millicore CPU at 20% CPU usage. Pretty scalable, right? Okay, so now again, we have talked about how Benthos can be done on a single job. Now, how do we platformize it? how do we send the Benthos job from a single team to basically org-wide? Currently, Benthos is used by MLEs, SDs, as well as basically any engineer that is working on a stream processing that wants a simple ETL dumb job. They are using Benthos. So we platformize it. How did we do that? Okay. So this is a single repo. Okay. So what we did is like we created a cookie cutter mono repo kind of like design pattern where each team will have their own mono repo for their Benthos jobs. So and then this job will have build, testing, and tooling configured, right? We provided this cookie cutter repo. We have like again CI/CD pipeline setup, how to use and all that. Now, every folder, basically these folders, these are separate jobs which are maintained by a single script that we have in this repo again. Now you can keep on adding more and more jobs, and the deployment will be easily taken care by the scripting that we have done, the tooling that we have provided. Again, yeah, same. As I said, we have business logic test and deployment as part of the each repo. They're separate. You can for each team they can scale their jobs separately without worrying about okay, how do we do tests and all that. If your test fails, your pipeline fails, but you know, right? Something is breaking. These tests can be run locally. You can fix it. Every team can scale their own jobs without worrying about again or going to platform thinking how do we fix it. They are the owner of their own jobs. Okay, so this is a generic dashboard that we built. That is, these metrics are provided inbuilt by Benthos. This is not something that we built. These are already there. We just created a dashboard. Every job that is deployed in ShareChat, they can just come to this dashboard, change the variable to their deployment name, and they'll get all the metrics, message rate, publish latency, and so on. Okay, I'll give mic back to Shubham.
Hello. Yeah. So now we have Benthos in production and a lot of Benthos also all about the rocket ship, and we'll see like how it's working. So this is the smallest use case we have. I'm not sure if you can see it properly, but it is like just 10 messages per second at peak. And this is like one use case, which we had like a very low throughput. So this is our configuration for that job. So we have like 25 millicore CPU as request and 100 MB of memory, which is actually high. We can decrease it further. Limits don't care about those. But so 25 millicore is running at like 10 messages per second. What would you think would be the cost of this job per month? Any guesses? It's a production job with monitoring everything. Any guesses on the cost? Like random guess. Any guess, like 1,550. Sorry? $10. Tell in rupees, I would say, not in dollars. $10 is very high. I'll just show it. It's actually 10 rupees per month. Like we have a cluster and it's shared. So this is actually production data. I'm not like I went to the dashboard yesterday, production dashboard, and I got it from here. It shows like it's 10 to 15 rupees per month. That's it. And we also process like some large jobs. So this is like a message that I sent out in our internal Slack. Like we had a use case where we had like around 2 to 3 Mbps of input traffic and around, I think peak was 2K messages per second. And I just did it done with like 1 vCPU and 1 GB of RAM. And we did a lot of optimization as well. And then this is where Benthos shines as well. Like all the optimization are very simple. You just need to set some config. Like Anuraj was talking about batching. So we did a lot of like pretty good batching. Like we did a linger of 500 ms. We had max in-flight of 64 to increase throughput. We also did compression. We tried with ZSTD, I think. I think we did LZ4 because ZSTD was difficult on the decompression side. So all of these, and it worked with just one core. And this is, again, the production metrics. It goes to, I think, 2K messages, so 1.4. Currently, it goes to 1.8K messages. Like it was yesterday, day before yesterday's peak. And what do you think would be the cost for this? Like 2,000 messages per second, 1 vCPU. Okay, it is not that cheap. Like I would say, like, but it's like still extremely cheap. I'll get back to that. But I will show you a bit of it in the config, like how you optimize. Like for example, like this is the optimization like every developer does in the Java code. Like they set the batching period, the batch size, or what compression algorithm to use, what hashing strategies to use. So all of these are very well defined. Like this is the entire setting that we have, and it works. I think around 300 rupees per month is the cost, the production cost per month, and it's pretty well. Like all of these jobs never fail. We don't have a lot of maintenance for those jobs. They just work. So which brings me to the end. Like I would say, like I've told all the good things about Benthos. Then I would say, like why you should not use Benthos. I would say because not everything can be like good. So I would say since it is like YAML based, I would say if you have a lot of business logic, YAML can get unwieldy pretty quickly, which can be difficult to maintain. The second point that we have seen with Benthos is because it's some people do use it as a black box, and which means there is a possibility when the error comes, it is somewhat difficult to debug. Like I would say, we have experience where we have seen the source code and we gone and debugged, but it is not as easy. I would say where let's say if things work, they work. If things don't work, you have to go into the source code to debug and see what is happening. You can't have a debugger on and see code by code what is happening there. And we have built out a lot of tooling, as I said. And without those tooling, I think it would have been difficult to maintain so many jobs. So, like as the meme says, like there's no such thing as a free lunch. You should know like what you are getting into and what are the trade-offs that you're taking here. And I would just like complete this talk with like how what we are at right now. We are at 40 plus active jobs. Our smallest use case that we showed is like 10 events per second. Our largest currently is 3K events per second, but we are expanding it. And all of those are like a single pod. Like we vertically scale. We don't horizontally scale. We can horizontally scale, but we don't like to horizontally scale, honestly. Vertical scaling is better. And we have like both PubSub, Kafka, Red Panda, HTTP sources and things. And actually, there are many more use cases in development. Like you'll very soon see this 3K going to 10K or something more than that. So this is it, and we are open for questions. So the errors for in production. Proxy for? So that is standard practice. Like if you have an error, you put into dead letter queue or something like that sort. So those are handled, like the output can handle dead letter queue, by the way. Yes, if you configure it. Like default, there are defaults. Like sometimes like some inputs might ignore it. It has a transactional model. So if the error fails, it will put the back pressure on the like the where the queue it is consuming from. But you can have a DL queue, and it is like a very easy thing to set up. Like when you have an output, you can add a DL queue on that. And if there's an error to send to a DL queue, you can also drop on error or log on error or send a metric on error. All of those are possible. Like send to a different queue, or maybe you just apply back pressure and retry. That is also possible. You can have multiple outputs. Like you can have fan out strategy. Like for example, like you want to have like A, B, C, D, depending on some let's say the message is saying the metadata. Like metadata is like type equal to A. Then you want to send to topic A. B, you want to send to topic B. All of those are possible. So you can handle things in that way. You can have some logic for error handling and do that. Fault tolerance from what perspective, I would say? So Benthos is stateless. We are not using any stateful operations here. It says you like if you're using something like batching, it is state is in memory. But what we are relying on is the guarantees provided with the sources and sinks. Kafka and PubSub by default provide at least one guarantees. So you can use those guarantees. What Benthos gives you is a transaction model. As long as the output is not committed, the input we are not committing. We as long like as long as we are not sending the message to the output, we don't set a like the update the offset and the producer. So what that helps is if the pod shuts down, we replay that instead of like missing a message. You'll never miss a message. It's at least once. As long as the sources and sinks support at least once. Like an HTTP will not support it. Yeah. Uh, I would say like Benthos, it's like I said, like Spark streaming and Kafka streams and all of those. They're more complex systems. We use them in ShareChat as well, but they all of them have their own niche.
Frankly, Benthos doesn't have a competitor when you talk about stateless processing, right? You can write your own Golang jobs, Java jobs that like stateless ETL jobs, right? But Benthos already provides it. And again, that is why Redpanda bought it. And they have now integrated there in the, so basically Redpanda was going to introduce something called transforms in their clusters, but then they realized Benthos already provides that. So they bought it. So currently there is no competitor as such a direct competitor until you go to like Flink or Dataflow, which are stateful jobs, right? So basically different work altogether.
You can use, I would say, Flink for stateless transforms as well, but it will be, from what I've seen, like there's an overhead associated with it, right? Like Flink has checkpointing, all those things. There will always be an overhead because you are doing distributed systems. Distributed systems have an overhead. Here, because it's simple and it is telling you, I'm not doing stateful things. I don't want to get to know that thing. So it is faster in that aspect. It does not have to deal with those things. No, we have a lot of transformation. I think this was the easiest one we presented. We have a lot of like transformation from, let's say, uh, like proto to JSON, and then we have business logic, like these fields should be present or not. We do an API call to do some enrichments on top of that, like add a new field. And then we again convert it, let's say, to an Avro format because the output might expect an Avro format. And then we write it to the output queue. So all of these things are done. This is the like for the presentation use case, we have taken the easiest one, which is the first thing that we started with. And what we have seen is that the best thing that any technology can do is people being pleasantly surprised with it, I would say. And people are like pleasantly surprised when they see Benthos and ShareChat. Like I go to a new developer and show him this, they're like, I want to use it in my next use case, which is how it extended. Like it's not like we just trying it like a randomly. I would tell like Shivam can tell, like Shivam was an intern. He was working with me. I just tell him like, let's try Benthos and see what is happening. We have not prepared demo, but I can do the demo. I think I had done a live demo when I did internal talk of this, but I think for the external one, I'm not sure because it's being recorded and I have to shift a lot of things. I have not prepared the demo, I would say. Maybe I can show it afterwards if people are interested.
Yes, it does. So basically everything compute storage or any niche cost, right? Basically transferring data from one place to another. As long as it is tagged, it is there. So even if it's, let's say it's not 300, it's 500, then again, does it matter? Yes, you can write tests which you can run locally, and then again that can run on your CI/CD also.
Yeah, I think we didn't present it well enough because we are pretty faster than we have test for every Venthos job, and we have a test runner that's part of the like all the repo that we have. And if the test fail, we don't let you like push to production. Uh, Maybe it is recorded. I'm not sure.
I would say ease of use, right? So with Java, things start ballooning up. You need one, like basically, I would say one class for each input, output. Then you have to say delivery guarantees, logging, metrics, right? And then this was not one use case. At that, like currently, that same repo that we did the POC for, this has 20 plus jobs running. For that, the Java code would have been unmanageable. I wrote the jobs 1.5 years ago, and I have not ever gotten an alert in 1.5 years. That is an amazing maintainability, right? And cost. So can no. It's a simple. You write your configs kind of like a DAG. You define a DAG. Input processing is like, okay, protobuf to JSON to protobuf to JSON, enrichment, API calls, and then output. There is no, so give the binary this file, it generates the code for you, and then there is no overhead, sorry, right? The code is already there. No processing again and again. It is not parsing it again and again and again. It knows what the steps. It just keeps on going.
think think of it like there is like Benthos is written in Golang, and like they have parameterized whatever is possible into this, and this is the parameters that you're supplying. So it is at build time when you do it first time, just supplied, and then it's the Golang code that is working on the back end. Like it's not like Benthos is something different. It's just a like configuration that it is providing to you. What it has given you is like the developers have worked extra hard to provide you so many sources and things and so many things, which I have not seen in any other like open source project till now.
Yes, multiplexing is possible. You can consume from multiple topics, and yes, so that is multiplexing, right? Same topic and different outputs, depending on your, like, I would say, kind of like a switch case, right? You define, okay, this is the condition that is matching. I want this to go to a different output.
For that, we need to define different.
The configs, right? So basically, you can write one YAML file, or you can write separate YAML files and then kind of like link them. So that it provides kind of like pluggable YAML files, kind of like, so that one YAML file, again, if it gets too big, it becomes harder to manage.
What is the main reason that things Benthos cost lesser in compared to Kafka?
I think it's highly optimized. It's written in Go. That's the main reason. Right, again.
I can give another reason. It's because it does not have the overhead that those systems have. Like those systems are built for stateful stream processing. If you build something for something and it is good for that, you need to do some coordination, things like that. And this does not have that. For example, so the reason, by the way, the first use case we introduced Benthos on actually was on the surface of a system. The system was built on Kafka Streams and it ran like 100K, 150K events per second. So, and we have maintained Kafka Streams, both of us. And we know like how bad it can be. Like auto scaling, we still don't auto scale our Kafka Streams deployment. And then the second thing would be like, we have been paged so often at nights, and then that is also efficient. And we have used it for stateful aggregations. So we'll not use Benthos there. We have like chosen the tool that we think is the best for the use case. First one. And second thing is Benthos is nothing special. Like underlying it, it is just Golang code. So for example, the code that you saw for Kafka producer, it is going using France Go, the same, like I would say, the library that Anurag was talking about. And the optimization that Anurag was talking about in the previous talk, we do it in the same thing at the YAML itself. So if you look at the code, it's like someone has distilled all the best practices and just put like a config in front of it.
At the large scale, video you guys feel like the consumer life in Benthos, like because I'm currently dealing with the Kafka stream at 3 RPM, 3 million RPM. The problem is like consumer life. So is the Benthos is the alternative for that at that scale?
So I would say we have not used it that huge scale. I'll tell you why. Because we have Kafka Streams and Flink, and we have stateful use cases. We did not have a stateless use case which had that higher scale. If you have a stateless use case, I don't think there should be an issue. Like it's just that we don't even scale horizontally, by the way. Like we tried not to scale horizontally because we know horizontal scaling has a rebalancing associated with it. We don't want rebalancing. We just want one single pod, 3 cores, and that runs for us. But if you want, you can have horizontal scaling. Like nothing is, it's a simple deployment. You just go to the, like if you're running on Kubernetes, you just define an HPA based on CPU. That's it.